FastMCP 2 implements dependency injection through a hierarchical resolution mechanism that caches and reuses dependency instances within a single request scope, ensuring efficient resource management and consistent state across nested dependency graphs. This pattern leverages the depends decorator to declare dependencies, which are automatically resolved and injected at runtime, with caching applied to prevent redundant instantiation. We will examine how dependency caching operates in this artifact, where a database connection is established once per request and shared across multiple repository dependencies, demonstrating the framework's ability to optimize resource usage while maintaining clean separation of concerns. From FastMCP, import FastMCP. From FastMCP dependencies, import depends. MCP equals FastMCP, caching demo. Def get DB connection. Print connecting to database. Hash only printed once per request. Return connection, active. Def get user repo DB equals depends get DB connection. Returns DB, DB type, user. Def get order repo DB equals depends get DB connection. Return DB, DB type, order. At MCP, tool. Async def process order. Orderid, SDR. Users equals depends get user repo. Orders equals depends get order repo. SDR. Hash both repos share the same DB connection. Return F processed order orderid. This code demonstrates FastMCP's dependency caching and reuse pattern through a practical example of database connection management. The pattern shows how dependencies declared with depends are resolved once per request and then reused across multiple injection points, optimizing resource usage. The implementation creates a dependency chain where getDBConnection establishes a database connection that's then shared by both getUserRepo and getOrderRepo. When process order is called, FastMCP automatically resolves these dependencies in the correct order, ensuring the database connection is created exactly once per request despite being needed by two different repository functions. This caching behavior is transparent to the tool implementation, but crucial for performance. The approach highlights several key benefits. It prevents redundant resource creation, maintains consistency by sharing the same connection instance, and keeps the tool function clean by handling dependency management externally. The trade-off is that developers must be aware of the caching behavior to avoid unintended side effects from shared state. This pattern is particularly valuable for expensive resources like database connections, API clients, or configuration objects that should be created once and reused throughout a request's lifecycle. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol MCP servers. The imported class will be used to create MCP server instances with customizable identifiers. From FastMCP dependencies, import depends. Imports the depends class from the FastMCP dependencies module, which is used for declaring dependencies in FastMCP applications. MCP equals FastMCP, caching demo. Creates an instance of FastMCP with the identifier caching demo for server identification in MCP protocol handshakes. The string parameter serves as a label visible to clients during protocol interactions, but does not configure functional behavior. Def getDB connection defines a function named getDBConnection with no parameters, serving as a placeholder for database connection logic. The function body is empty, indicating the implementation would be provided elsewhere or in a subsequent code segment. This is a standard function declaration pattern used to establish an interface for database access.
Print connecting to database. Hash only printed once per request.
Prints the string connecting to database to standard output, serving as a single status message per request to indicate database connection initiation. The comment clarifies this message appears only once during each request processing cycle.
Return connection. Active.
Returns a dictionary with a single key-value pair where connection maps to the string active. This indicates the current connection status is active.
Def get user repo db equals depends get db connection.
Defines a function, getUserRepo, that accepts an optional db parameter, which defaults to the result of calling getDBConnection via FastAPI's dependency injection system, depends. The function will receive a database connection when called, with the connection being managed by FastAPI's dependency framework.
Returns db type, user.
Returns a dictionary containing two key-value pairs, db mapped to the value of the db variable and type mapped to the string user. This creates a structured data object that associates a database reference with a user type identifier.
Def get order repo db equals depends get db connection.
Defines a function, getOrderRepo, that accepts an optional db parameter, which defaults to the result of calling getDBConnection via FastAPI's dependency injection system, depends. This creates a dependency that will automatically resolve the database connection when the function is called within a FastAPI route.
Return db type, order.
Returns a dictionary with two keys, db containing the database object and type set to the string order. This appears to be a structured response format where the database connection is passed along with a context type identifier.
@MCP tool. Async def process order.
Declares an asynchronous function named processOrder and registers it as an MCP tool using the @MCP tool decorator. This makes the function available as a callable tool within the FastMCP framework, with automatic handling of its name, description, and input schema based on the function's signature and docstring. The function is marked as asynchronous, indicating it will perform non-blocking operations when executed.
Users equals depends get user repo.
Declares a dependency injection parameter named users that will be resolved by calling the getUserRepo function when the endpoint is invoked. The depends marker indicates this is a FastAPI-style dependency that will be automatically injected into the root handler.
Orders equals depends get order repo.
Declares a dependency injection parameter named orders that will be resolved by calling the getOrderRepo function when the containing root or service is invoked. The depends wrapper signals FastAPI to handle the dependency resolution automatically, injecting the return value of getOrderRepo into the orders parameter at runtime.
Return f processed order ordered.
Returns a formatted string indicating successful processing of an order identified by ordered. The f-string interpolates the ordered variable into the message processed order ordered. FastMCP2's dependency injection system demonstrates a clean hierarchical resolution pattern where expensive resources like database connections are cached and reused within a single request scope. The depends decorator creates a dependency chain where getDBConnection is called exactly once per request, with its result automatically injected into both getUserRepo and getOrderRepo. This transparent caching mechanism ensures consistent state sharing while optimizing resource usage, the connecting to database. Message appears just once despite being needed by multiple repository functions. The pattern maintains separation of concerns by handling dependency management externally, keeping the tool implementation in process order focused solely on business logic. The trade-off is that developers must remain aware of this shared state behavior to avoid unintended side effects. But the performance benefits for expensive resources make this a valuable pattern for request-scoped operations.
The decorator sleeps silently, yet the database connection dances through every repo like a shared secret.